So our next speaker is JK Gunnink, a cloud and software engineer, Google Cloud expert, and true harbinger of DevOps. In this session, he will dive into a real-world example to show you can run your entire SaaS on Google Cloud, from writing and deploying code to monitoring, alerting, and code reviews all on the platform. So please join me in giving a warm welcome to JK Gunnink.
Thanks. Thank you very much for that. This is actually a really useful segue on the previous two talks. So if you were here for Anka's talk and you've been developing your own SaaS and you now, which may include agents, and you now want to monitor that and operationalize it, I'm going to be talking about all the different types of tools that you can use to do that, all on GCP. So you might have come across this problem before, tool sprawl. Now this intentionally uses AI-generated images, so they're not correct, but let's go with it. So you might have come across things like Datadog or Jenkins to build your application code, Datadog to do logging or tracing. You might have used various cloud providers to do different bits and pieces, and like alerting through PagerDuty or something like that. Well, I'm here to tell you that instead of having all these different tools and various subscriptions and things that your operations team or development team need to learn about, you can all keep it inside the single platform. And that helps from a bunch of different perspectives, such as not having to learn different tools, from security points of view, about not having to set up API keys and then make sure that they're secret and then rotate them, that sort of thing. And I've worked at quite a number of startups in the last few years as a consultant helping with these sorts of problems. And I see it mostly when companies tend to want to get certified, some kind of certification like ISO 27001 or SOC 2, and they've got tools everywhere. I'm working with a startup, and when I arrived, they were using Notepad to keep a track of their tasks, and they were using Telegram as their company chat. So there's all kinds of different tools that exist that do all kinds of different things, and they tend to all promise that they will save your developers time. That may be true, but when your developers have to save time by learning so many different tools, maybe the value proposition of time saving goes away. And if you've got a single platform that you can understand how everything works, it can be a lot simpler in the grand scheme of things. So if you're on GCP, you should just use the tools you already have. Now, I asked AI to generate an image for me for this, and I was actually really impressed with this picture. It's really cool, and it shows Google as a cloud platform, and it has all of the different various tools and capabilities that GCP provides, talks about. You've got the observability city there, and automation city, and in the background you've got serverless going on. There's Cloud Run, and yeah, as a cloud platform, I think it's actually a really neat picture. And GCP does have all these tools that you can use to run your SaaS. So, quick agenda of this talk is that we'll build, deploy, and operate a feature for a SaaS on GCP. So we'll start by writing the changes with help from Google's AI tools. If I asked who's using AI in their development workflows, I'm pretty sure most people would put up their hands to say, using Gemini or Cursor or some variant of that. And so writing the code is actually really useful. In GitHub, there's a built-in integration that Gemini can automatically review your code. We've recently implemented this where I'm working and found it to be saving a lot of time before it gets to a human reviewer. So you reduce your feedback loop, duration of the feedback loop. So when a developer puts up a code change, they get that instant feedback from the AI before they ask a human to come along and review it. After we've written our code, we'll then deploy it. So we'll be talking about automation, how we can get our changes from pull request merge to production. And then once we're in production, how do we operate and monitor that? So we need to make sure that our service is available. We can set up alerts, and if there is a problem, how can we solve it? So I built a SaaS last year, which I released, called Rocket Flag, which is a feature flagging tool. And I'll show some screenshots about how this is working, just to give you guys a real world example. And if you want to, you can sign up. Yes, it's a shameless plug. You can sign up, and later on at the end of the talk, I'll show the alerting system live in action. So if you do want to register, we can see the registration alerts coming in towards the end. Again, optional, you don't have to, but if you want to. All right, so let's go through the scenario of this presentation, which would be to follow the life cycle of a feature request. Well, hopefully the product manager that we're working with knows what they're doing, and they've given us a well-made Jira ticket because, you know, we get them all the time, right? And we never have to ask any questions. But assuming that that does happen, we pick up the ticket and the work begins. If we're doing TDD, you'll start off by writing all your tests first, which no one does. But we pick up the work, the tests are written, and then based on the specifications, we write our code, and then after it's completed, the tests that we've got go from red to green on our dev machine. We then push those changes out to a feature branch, and then automated checks will run. We might do a code review from an AI tool or a human reviewer, or both, preferably. And then we will merge the code, deploy it, test it in QA, and then release it, and finally operationalize it. So, phase one, code and collaborate. So this is optional. Lovey gave a great example before with Cloud Code, where you can write using Cloud Shell in collaboration with Cloud Code. It's an inline video web editor for editing your code. It's a VS Code fork, and it comes with a bunch of Google tools already pre-installed. So you've got things like Gemini, autocomplete. You can ask it. It's got the Gemini CLI there, and other bits and pieces. Pre-built tools, so you don't have to install Python, Go, Terraform, Ruby, whatever you're doing. So it's zero configuration. You just open it up and off you go. I put this as an optional because it's great to do small, lightweight tasks, but if you're doing like serious, lots of heavy features, lots of development, you probably want to do this on your own machine. But it is there available to do writing code. So once you've written your code, it'll go into code review, and you might have some status checks. Hopefully you have status checks before you merge anything. And Google Cloud integrates with GitHub and GitLab, so you can host your code wherever you like. But at the PR stage, you'll want to run those automated checks to make sure that the change that we want to bring in to the main branch is suitable. And Cloud Build is GCP's serverless CI/CD platform. So from there, you can do things that you might want to do in other tools, but you run your tests, do linting, that sort of thing. But you might ask the question, well, why not my CI/CD tool here? I've got BuildKite, or I've got GitHub Actions, or something like that. It's a good question, and it is tempting to use those tools, especially if they're just running tests on the code. You may want to do that, but it is another tool to manage. And if you're doing this at any kind of scale, it's just another case of tool sprawl. But when you want to deploy code or make changes to your live environments inside Google, there's a security consideration of having to provide either API keys to push to artifact registries or make changes if you're doing Terraform or something like that, or workload identity federation with GitHub Actions. There's just a lot of extra stuff going on to make it work, whereas you kind of get that out of the box with service accounts and Cloud Build. So, and this screenshot, by the way, is a screenshot of the output that Cloud Build is sending back to GitHub. So you can still see your changes without having to go into another tool if that's the concern. So it can be useful. And this one, I think, is just a Terraform output from memory. Yeah, it is. So this was when I was doing Terraform for my project. I can see the output of Terraform without having to go into the build logs to see that specifically. Okay, so we've merged to master. The developers' coding work is done, sort of. And now automation, hopefully, takes over and getting that code into production. I would hope that automated machines are doing this and people don't have access to production machines, but usually that's more of a dream than reality. And so this is where the fun starts. Let's get started with deploying with automation. So continuing to talk about Cloud Build just for a second. It's one of my favorite tools actually on GCP. It's quite straightforward to do your checks or your build process in Cloud Build. And you can see from the screenshot, hopefully it's big enough, that we're doing an install of the dependencies, we're running the tests, we're building a Docker image, we're pushing it to artifact registry, and then we're deploying it to Cloud Run in 28 lines of YAML. So each step is pretty straightforward. It's sort of 3 lines to say, in the first one, install the dependencies, okay? And then it says it uses the npm cloud builder, and we're just doing npm CI to install cleanly the dependencies from the package lock. And then the next one, npm test. So it's not terribly complex to use, and it runs inside your own GCP environment. So when we want to push to artifact registry, for instance, the service account that's running this Cloud Build instance, we just have to give it permission to write to artifact registry. And similarly, we just have to give it permission to deploy to Cloud Run. Now you can separate these out and have their own separate builders for different tasks and things like that, but for the sake of simplicity, I've just listed it here in a few lines that this is what you can do with Cloud Build. And by the way, Cloud Build has a really generous free tier. I don't think I've ever been charged for Cloud Build. I use it a lot. I think it's like 1,000 minutes a day or something like that. It's a ridiculously high amount for free. So check it out if you haven't. But once we've built our application and we've tested it, we have to store it. And the reason why we might store our application is that in case we want to roll back to a previous version, or we want to be able to deploy it to multiple regions, that sort of thing. So we use Artifact Registry to store the built containers that we've produced. And Artifact Registry is basically like a warehouse for all of our versions of our app. So with Docker, you tag your images with, hopefully not latest, but a git hash usually, or a git tag, and then you can easily find the artifact that you want to deploy. But Artifact Registry allows us to store those versions, and if we ever need to go back, we can just re-release an old version. But once we've got our app, we want to ship it out, we can use Cloud Run. Now, Lovey was just talking about this before with the agent stuff, but Cloud Run is basically a serverless compute platform. It can scale to 0, and so for those who don't know what that means is if no one's using your app, you don't pay because the service is not running. It only actually charges you when it's serving a HTTP request, or if it's doing a job or something, but it only charges you when there's a HTTP request in flight. So if your Cloud Run service can serve a HTTP request in, let's say, 300 milliseconds or something, you only pay for 300 milliseconds of use. Your container will actually, Google will keep it warm for a little while. So if no one's using it for an hour or so, it will go cold and it needs to boot up again. But Google will keep it warm for about 10 minutes, depending on availability, which can be very useful if you're getting a request every minute or so, or every couple of minutes, because once it's warm, you don't have to re-warm it. But Cloud Run's really developer and ops friendly. From the screenshot, you can see that you get a whole bunch of graphs out of the box around, request latency, memory, CPU consumption, that sort of thing. And you can configure this to your system requirements. So I think it goes up to 32 gigs of RAM and 4 or 8 CPUs of usage. So you can go all the way up, and you can also, on the other side, go all the way down. If you have an app that's been built in, say, Rust or Go, that uses really, really low memory, has really low memory requirements, like Rocket Flag, for instance, you can configure 128 megs of RAM as a minimum, and split out your CPU usage as well. So it's really quite configurable. All right, so we're in production. Now we've got to operate and respond to our work that's been shipped out. So the system metrics this is the same screenshot from before, but the system metrics provided out of the box from Cloud Run sort of give us this visual indicator without having to do anything. This is all provided out of the box. In other services, you might need to configure something like Prometheus to get these kinds of graphs to understand the usage of your service. But you can see, I think it's just in the top right there, the request latencies, and you can see like your P99, your P95, that sort of thing, to see how quickly your app is responding to service requests, what the average response time is for the full flight versus just the time that your container served. There's all kinds of information in here, which is really, really useful to see out of the box. And you also get a lot of, you also get the logging out, from Cloud Run too. If you want to do more advanced stuff with logging, you can go to Google Cloud Logging to view all your logs. And in here, there's a really neat tool where you can, go, I just want to see the last hour of logs, or I want to see the last 10 minutes. Quite easily, there's a little drop down. You can just type in like 10M and it will show you the last 10 minutes. If you want to see your logs with the Logs Explorer, you got a very configurable querying tool, and you can either type it all out yourself, you can get Gemini to help you, or you can use the filters, which again, very useful on the side there, and you can filter by regions, you can filter by service names, all kinds of different filters that might be useful to you. So in this case, I'm filtering by just Cloud Run revisions, and the requests I want to see is the particular log name and the log type of info. So if I would just want to see error logs, for instance, I can go in here and look at that. The other thing I want to touch on is proactive alerting. So this is the demo I'll talk about in a minute, but you can set up all kinds of alerts in here. So you might say, okay, I've got Slack, I'm using that as my chat, or I'm using Google Chat. And I want to be alerted if the error rate is if I'm getting 500s and that error rate is above 1% for 5 minutes, I want to know about it. Or I want to know about it if there's any error. So for me, which is like I'm running Rocket Flag. It's recently it's a new app, and so I want to know about any error. So sometimes I get pinged all day, but then it means I'm across it very quickly, and I know exactly when a new user is signing up, for instance, or when a payment's been received, or if a health check's failing, or if there's any kind of error, it'll pop up. And you can have alerts sent to your phone. You can have them sent to Slack, Google Chat. There's a whole bunch of different channels that you can use, and it's all included out of the box. So you don't need to set up any additional tools. And something that's fairly recent, I guess, but has been improving significantly since I've started using it, is the generative AI advice that you can get inside of the console. So there's a lot of talk about, help me with this error kind of thing that you might see in your editor. But what about once your code's already running? So one of the really neat things that LLMs are really useful for is ingesting huge amounts of information and synthesizing it really quickly to give you some kind of response to help you understand what's going on, which would take humans a very long time. So if you are generating millions of logs, in fact, I was working at a company that was generating a petabyte of logs a day, which is a lot of logs. And so if you're trying to make any kind of sense of that, it's really, really difficult. But if you're looking at logs, for the last 10 minutes or something like that, and you're generating that volume, you can have an LLM look over them for you and synthesize them quite quickly. Now, Rocket Flag does not generate that much logs, but when you pick on a log, you can press this button up the top left that's in the screenshot there to say, explain this log for me, because I don't understand it. The pre-filled text is the one you're seeing at the top right, which is coming from Google in their preset prompt. But it explains in the bottom right there, the log entry says that this is a successful HTTP GET. It went to this Cloud Run service, and it was the revision of this version. So every time you deploy Cloud Run, you get a new revision. And it happened in the South America West 1 region. It also says some other useful information about it, which was that it was a 200, which is fine. But it also completed with low latency. So you can see in the in the response time there that it was 4 milliseconds, I think it was. Yeah, at the top. And then the one underneath as well was 4, and then 2 milliseconds. So the Cloud Run service was responding to that customer's request in 4 milliseconds. So sort of helpful information there. You can also use it for errors, which is really cool. And in a demo that I saw a few years ago at Cloud Next, they showed an error that had popped up after a change. Gemini was able to find the error, explain what the error was, and also point to the line of code that introduced that error so that the developer could go from alert to a potential fix in like a minute. And if you've ever worked in any kind of SRE sort of operation before, where you may not be across the code, this could take hours, if not days, to find. So the fact that it's gone from days to minutes is pretty awesome, and it's very useful as well. And it doesn't require any extra configuration or security tooling. It's all built into your logging. All right, some conclusions and takeaways. We've gone from an idea or a bug fix to a fully released and monitored production feature in one platform. So we've planned for it, we've written the code, we've built it and tested it, we've then deployed it, we're running it, we're monitoring it with our logging and alerting and all those sorts of things. And we can repeat, we can go on to the next thing. DevOps is not a job title, despite what you may see in Seek. It is not. It is a feature. It is a culture, of methodology. It's a philosophy of getting things done in an automated way and in a collaborative way, really to just improve software delivery. Now, there are some additional tools here which I didn't have time for in the talk, but I wanted to quickly touch on. One of them is Identity Platform. This is a sort of little known about tool. Not many people I see really talking about it. It's more popular in Firebase, but it's a replacement for something like Auth0 or Okta, if you're using any of those platforms. Identity Platform allows you to do password and passwordless sign-ins, sign in with Google, sign in with Microsoft. You just need to configure it. And then again, it's already built into the platform, so you don't need to separate out special API keys. You can also customize your JSON web tokens if that's what you're using. Cloud Trace is also another one which I didn't get in time to talk about, but it's a really cool one. So this is if you're doing any kind of OTel stuff, which is like telemetry of your application. You want to understand how long it takes for a request to come in, go through your various microservices, and then come back out and respond to the user. Cloud Trace is really useful for that. You can see the latency between services and to databases and things like that. So recommend Cloud Trace. Error reporting is like your centralized error dashboard. So if you're getting lots of errors in your apps and there's all different kinds of warnings and errors popping out, error reporting is like a dashboard to show you all the different types of errors, how often they're appearing, when was the last time something was seen, any new errors that are showing up, which you might be able to correlate back to a change. So error reporting is very useful for that sort of stuff. Cloud Armor, which is a WAF. So if you're getting peppered with like unwanted traffic, let's say, there's all kinds of stuff out there. So people trying to get to see your application's environment variables or trying to hack you, that sort of thing. Cloud Armor is really useful for that. And then Cloud CDN, again, to a content delivery network to deliver your assets even quicker. So it's all built into the cloud, to the Google Cloud Platform. So if you're running your if you're running your service on GCP, you don't really need to use these other tools because you've already got it built in here. So finally, if you can take 3 things away from this talk, is that you can reduce your context switching and fatigue by using the tools that you already have inside Google. You can automate your entire application lifecycle with Cloud Run, Cloud Build, and all your logging tools and things like that, and alerting. So use your logs to notify you of significant events in your system. So for example, a new user has registered or someone has made a payment. Okay, did anyone register? We can go into the logs. Yep, we go register. Okay, thank you. So if we go out of here, and here, so yeah, this is the Rocket Flags Alert Google Chat channel that I've set up. So you can see that there was an error actually 17 minutes ago. So I'm sorry if you have an error. I have to look at that. But this is a custom log metric. So if I want to, I can see more information. But there's the alerts coming in there for into the alert channel that I've set up, and this is based on a custom metric. So if the internet is working quickly enough, yeah, it seems like it is. You'll see that I have a log-based metric alert set up, which is for no severity. I'll just close that because it's got someone's email address in there. But it showed up with the log-based metric of new user has registered, and the logging system is picking up on that specific log line. So they want to know. So I want to know. Okay, I've got a new user. I want to be alerted to that, so I can keep a track of new users that are coming into the system. Okay. So this is my socials. If you want to connect with me and tell me of your alerting problems, I like hearing them, believe it or not. So let's connect. And I think we've got some time for questions. So if anyone has any, I would love to hear them. Yeah.
Yeah, about Cloud Build, how is it triggered? Like, you somehow trigger the from GitHub actions when a PR or a merge happens? Or?
Yeah, good question. There's quite a few different ways you can trigger. For my use case, I have a trigger which runs every time there is a merge to a branch proposed. So not actually merge, but a proposed merge. So you can configure that. I've also got a trigger that runs when there is a change to the main branch, which is to deploy automatically into my development environment. And then I have another trigger which is to run on a tag. So when I do a git tag and I push that tag, a different trigger runs to push to production. So yeah, you can configure Cloud Build to listen on Git events which happen in your repo, and it will execute based on those triggers.
So on the time that the build is running, is it counted as a GitHub action running, or?
No GitHub action
Okay.
is running. Yeah, it's a Google Cloud Build action.
Okay, and the logs that you were talking about that were sent to GitHub, so
Yep.
they are sent to GitHub, but yeah, they don't appear in the list of actions, but somewhere else.
The logs that are produced from the Cloud Build output are sent to GitHub for that particular trigger. They are also stored in the cloud logging. So the logs are piped through basically to GitHub and stored as a record of that change. Yeah. But it's not using GitHub Actions. Yeah.
Okay, can ask maybe more later.
Yeah, sure.
Yeah, I mean, entire businesses exist around some of the components here that you've talked about. So places like Datadog for the observability and reporting, and then other cloud providers like AWS and Microsoft have their own sort of platforms for a lot of this as well. What are the main differences between something like Datadog and GCP, or what things like AWS has to offer in this space as well?
Yeah, it's a good question as well. Those services are really aimed at large usage with complicated workflows, which you may not get easily from the platform operator's provider offering. So one of them specifically is a trace thing that I've used on Datadog before. I really like Datadog's cloud tracing feature that they have. It's for small SaaS companies that are doing like the basics and just want to get everything done. You might just be happy. You'd be good enough to go with the cloud provider's option. For the enterprises, the big companies that need specific workflows or specific integrations with things, that's where those providers, those third parties, can come in really useful. Yeah.
And what about comparisons to tooling on AWS or Azure?
If your workloads are already in Azure or AWS, I would say use those tools, because you don't want to be, well, I wouldn't choose to be sending logs between providers or setting up alerts in one provider if you're using another provider's compute, or analytics in one provider and analytics in a different provider, and then you've got to manage logs across both. Yeah, I'd say pick one and go with that. Each of the different providers have their own unique value prop. So I really like Google's container Cloud Run service because it has the sort of like Lambda-ish effect of AWS's Lambda of scale to zero, instant startup time, except it's your code because it's in a Docker image. AWS also have different container runtimes which they do offer, but I find that GCP's one for containers is better. But equally, I think Lambda's a great service, and it's probably a bit better than Cloud Functions, for instance. So there's different, each provider has a different benefits and disadvantages. And so, but my main takeaway would be, if you're in one provider, try and stay with that one provider because you get more out of it if you use just their features, yeah.
Thanks, JK. So I'll build on his question, but thanks for the presentation. Some really interesting keywords there, DevOps, SRE. Now, coming to his question, specifically around SRE, he was asking about the benefits of using cloud monitoring or specifically Google Cloud as opposed to Azure and AWS. Do you really think creating that sync from the cloud logging to something like BigQuery can be really useful here if I'm looking at using more of the Gemini stuff, the AI stuff, doing analytics, rather than reactively working, putting the SRE hat on and working on the alerts proactively, doing a bit of analysis in BigQuery, using the logs internally itself, and then predictively doing a proactive actions on the logs or the errors or even the traffic, the counters that you were showing there. What's your thought on that as a differentiator?
Yes. I think, yeah, that's a whole workflow. That's a whole person's job, I think, doing all that stuff. The tools that I'm talking about here is really just allowing anyone in the development team to go, I need to understand this, and I need to understand it quickly, and I may not have that SRE background or whatever. At scale, definitely, if you are producing that many logs and you want to send them to a data warehouse and then run a query to get a specific thing back and then do some analysis on that, it's a great use case for BigQuery. One of the things with cloud logging is that it keeps logs for 30 days, I think, or 40 days.
They haven't increased it.
Yeah, you can turn on extended logging to a bucket or whatever, but yeah, I mean, yeah, the whole workflow of piping your logs out to BigQuery to do analysis on later is, yeah, that's a whole different part of something I didn't get to in this talk, I guess. And it can be useful for jobs, not just for SRE, but for also like data analysts, if they want to see like, you know, how long it's taking for a workflow to occur, or how long it goes from someone signing up to getting their first, well, in my case, flag deployed. Or how long it takes for someone from the time they sign up to get a third party to hit their API, to hit the API for fetching a feature flag. That would be an interesting metric to track. And if you're doing that at scale, then yeah, BigQuery would be an awesome option for that.
Thanks, Matt.
Yeah.
Sorry, this will be the last question. Sorry. Okay. You can go. Sorry. If you
There you go. Okay.
You can ask one last question.
Okay. One or two questions. So, so you mentioned your CI checks. So I want to know what the checks you're running on your ID locally, and the second question is how to ensure your code is secure in terms of CI checks on your pipeline.
Okay. The first question around running checks locally. For me, I will build all my features with tests. So, because I don't trust myself to do the right thing in the first go. So what I'll do is I'll write out a bunch of use cases of what I want this particular feature to be. I really like TDD, so I tend to do it. And I'll write out, okay, I need this feature to do this, 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 and this. And I'll know I'm done when they all go green. So in terms of checks locally, it'll be writing those tests and then executing them. The second question about secure code, I'm not quite sure I understand your question.
So you're open to the internet. It is internet facing, right? So your application is internet facing. So I want to know no bad guys coming into your service.
Okay.
Yeah.
Yeah, cool. I talked a bit briefly towards the end. There's Cloud Armor, which I use as a WAF, which sits on the load balancer, and it's a web application firewall that blocks any traffic that is unwanted. So I have whitelisted endpoints which are publicly accessible, and it's only one, to be able to hit the service at that endpoint. And so when the service responds to that endpoint, it's basically you're programming at that point. There are a bunch of things that you can do to prevent access by, for instance, for Cloud Run, you don't get access to the underlying machine that's running it. So, and it's in the Docker container. So it'd be pretty hard to get in through that endpoint, as well as run any kind of code, simply because you don't get access to the machine. You can also do other techniques such as multi-stage builds with your Docker images. So my final build output is using a Scratch image. So I build my entire application in Go. The backend's written in Go. And then it compiles to a single binary, which I then copy across to a final image, which is just Scratch. So there's nothing in the container really except the binary. So it makes it really, really hard for anyone to do anything. But again, that's quite a wide area of discussion. Yeah. I hope that helps. Thanks. Thank you very much, everyone.